Hello. Today we're going to speak about the science of copper, presented by Catherine Morrison in Fulfillment of Chemistry 515, Concepts of Inorganic Chemistry. We are going to be speaking about the objectives of this presentation in the following: the history, the production, the extraction, physical properties, practical applications using copper, mining for ore and its downside, the method of measuring the amount of copper, biological uses, future applications, and also where to get more information about copper. As you can tell, we are going to talk about copper. We have a timeline for the copper and when it first was documented. In 9000 BC, natural copper made into crude weapons and jewelry and some decorations like bowls or cups. In 4000 BC, we have the crude beginnings of metallurgy, and it is used to make some bowls, sturdier weapons because of the alloys. 3000 BC, we see copper being used more with the allies because metallurgy is being refined and is used for jewelry and decorative pieces. Also, any weapons that were made are sturdier and more durable. In the 19th century, copper was used for the early motors and telegraph. In the 20th century, we see an explosion of use in construction, electrical, wiring, and microchips. In the 20th century, we see the applications being increased for more digital hardware and the development of medical use and delivery of drugs in items such as nanoparticles. Where is copper produced? It is mainly Chile, Canada, Zambia, the Sheba region of the Congo, DRC, and the United States. At the time of this paper, it says that the United States was the third largest producer of copper. How is copper extracted from the earth? Well, as you can see, this is an actual mine, and along the walls you can see copper ore all over. The main ores that are produced from these mines are copper pyrites, which is CuFeS2, cuprite, which is Cu2O, and copper glance, which is Cu2S. Of these three copper pyrites is the ore that is purified because there is more of it. The of retrieving the copper follows is the copper pyrite is crushed from the larger rocks into smaller rocks. And then that ore concentration is sent to a flash furnace. In this flash furnace, it's high heat. And in this heating process, any extra water molecules, gas products are sent out the exhaust. And then we have this that's known as a slag, which is a component of impure minerals and ores that are lighter than the copper. The copper then goes through and is known as a copper matte. The copper matte goes into the converter, and in the converter it is heated up again. Here more gas is extruded through the exhaust, and then we have another layer of slag, which is iron ore and other minerals that were not taken out from the first production. Here, this copper that goes through here is called blister copper. And here it's about a 60% pure copper. In the anode furnace, more heat is added and more ionic water particles are sent out with any other natural gases involved. We are now left with fire refined copper. In this product, it's about a 90% pure copper. It is then sent through to an anode casting machine. In this anode casting machine, it is poured into these blocks, and then these blocks are sent over to the final processing area where these anodes are sent into big vials with solution, and electrolysis occurs. When this occurs, any impurities are pulled out and attracted to the cathodes that are attached to that. And now we're left with nearly 100% copper. Some of the properties of copper that come from the periodic table, as you can see, it's in the D period, and it's known as a transition metal. Some of the properties that it has is its atomic number is 29. The valence number is +2 in its natural state. The electron configuration is argon 3d10 4s1. If you notice, naturally we would think it would be 3d9 4s2. But in this case, an electron from the s2 lowers the energy to a 3d10, and we're now left with 4s1. This is a stable molecule, and it's a good use to react because now we have an open valence to connect with other products. The next three items are definitions for metals, and in this case they have shiny luster appearance, electrical conductivity, malleability exhibited, which it does. Some practical applications are for construction, and in the construction it's actually used for roofing material, and in the roofing material copper makes a nice addition and makes it look pretty, which makes the home better to sell. And also copper is a lighter material, it is heat resistant, and it's also antimicrobial, so it has a longevity for the use. Next is plumbing, heating, and insulation. Because copper insulates very well, in air conditioning units, the air will go through there heated and stay heated. In plumbing, any water that goes through will go full flow, and because it is antimicrobial, there will be a lesser chance of contamination of bacteria. And because copper is so ductile and malleable, it is able to be spun into super thin wiring that is used for electrical purposes. And it is also used as a cooking utensil, although more popular is the bronze, which is an alloy. And what it does is it has an even cooking place so that you don't have hot spots on your food or raw spots on your food. And finally, it can also be used for electrical components. As you can see, they can be made so small because of its ductile malleability that it can fit on these small circuits. Next thing we're going to talk about is the hazards of mining. Although copper is abundant, it's still not found a environmentally friendly way of getting it, because of the fact that in the beginning we have a natural, beautiful, vegetative, full landscape. Once mining begins, it takes off the vegetation and leaves these mines of open dirt. And one of the reasons is because of the erosion of soil. With the erosion of soil, because it has no more vegetation, winds, air, water, rain will cause any of the topsoil, which is the fertile soil, to wash down, and so that nothing can be grown from there. Also, it uses a lot of resources from the local population. It uses land and it uses the water. It also can cause water contamination. Yes, there may be some spill off, but what is also not figured in is that copper does, when it's mined, throw particles into the air. These particles will go and flow into the water as water runoff. This water goes into the natural aquifers and can get into the local water supply. And then finally, air pollution. Because of the particulates that are left over from the mining that go into the air, then because of the transporting, digging, mining, smelting of the processes, all these processes are emitting CO2 carbon emissions into our now depleted ozone layer. Some of the methodologies that we can be used for this to quantify copper is an atomic spectrophotometric technique. This technique, we have molecular spectrophotometric methods. And then we also can utilize sensors, which can come as electrochemical, colorimetric, or optical. And then it could also employ HPLC, RP, HPLC, and IC. All of these can monitor small amounts or trace amounts in solutions, in body tissues, in soil samples, food samples. The most sensitive ones would probably be the molecular spectrophotometry, and the ones that utilize the sensors are probably the least sensitive. Some biological uses is in our body, it is a trace element, and we do use copper in our systems because it is used to transport proteins, enzymes, and other metabolic processes. The pathway in the body is that we ingest it through food and water, and at times, because we are depleted, we take minerals as well, vitamins. It is absorbed into the bloodstream after it is broken down into our stomach. It is transported to the liver. Then from the liver, it is distributed to the organs and cells via ceruloplasmin, which is actually a copper protein, and albumin. And with the albumin, the copper will attach to it. These are all used as enzymes and proteins and catalysts in all areas of the body, including intracellular respiration. For example, it can be used as lipolysis, where it breaks down fat cells, and also it converts dopamine to norepinephrine, which is used for our central nervous system. Some future applications is they are now rethinking the mining processes and trying to figure out how they can minimize the environmental aspect. And they are now finding some ways of recycling copper and using it to make water and soil safer for the environment. I've attached a website if you'd like to go in and look for it around just to see what more information is out there in that case. And it's also being used in our medical field as a treatment for cancer. And the nanoparticles are being used as a delivery system for other drugs to minimize the exposure or the ingestion of these drugs to people, because sometimes the route, whether it's oral or injections, can cause some minor side effects, whereas these are so small, will not cause those side effects. So that is being looked on now. Final thoughts. The science of copper is interesting in the fact that there are applications of use that span from the external world to the internal world of the human body. It is all based in inorganic chemistry, from the process of how it is extracted and purified by electrolysis, for example, to the trace elements needed in the human biological system to keep it functioning. Just with the catalytics going on, the intracellular systems going on, it is just amazing how copper is involved in so many processes. And here are the references. Thank you so much for listening.